today we are going to look at quadratic equations and horizontal shifts, and then we're going to connect it back to some vertical shifts. There's a video in the YouTube channel that's about the vertical shifts, so I've linked that below in the description. So to enter our functions, we're going to start with a parent function. When students are first learning, that's always the best way to start to understand the shifts that happen and to understand the equations. So I'm going to scroll down to my table and enter my functions. We've done this before, so I'm going to go through this kind of quickly here. I need to go to Tools, and I need to define both my variables, both my functions. So I'm hitting Execute to get into it. So I'm going to start with the parent function. So x squared, hit Execute to set it. I'm going to go back into Tools and define my g of x function here. I like to start with 2 because then I can use the negative and the positive of the function. So I'm going to use the negative version. This is a scientific calculator. I have a negative symbol above the subtraction. So to do that, I hit Shift, negative, and then I'm going to enter x squared, Execute to set. I like to have the calculator set the table up for me, so I'm going to go back into Tools and define my range. I just tend to start with my standard negative 10 to positive 10. And then I'm going to skip down to Execute. Execute will fill the table in for me. Now, once I have it, the great thing about this scientific calculator is you get dynamic graphing capabilities by using the QR code. If you have the handheld calculator, it looks just like this. All the steps are the same. The difference is you are going to hit the Shift and then the X variable, and you're going to get this QR code. You're going to use your mobile device to access the dynamic environment. Since I'm already in the dynamic environment, all I have to do is hit this sticky right here. So if you have the handheld, you're going to use your mobile device, tablet, phone, and it links you to the dynamic environment. And when you get into it, you're going to actually see the graph. Sorry, I'm on a computer screen, so it tends to be very big on the computer screen. But you're going to see the functions you entered. You're going to see a graph. I happen to be able to see my emulator, but you'll have the handheld. The table is on the handheld calculator, but once you're in the dynamic environment, you can also get the table. So all I have to do is go by the functions and click that table icon, and it puts the table there for me too. But once you're in this dynamic environment, you can play around and you can manipulate. And that's what I love about this, because now I can make some conjectures, and we're focusing on horizontal shifts in this particular video, but I could then apply what I already know. If a student's already done the vertical shifts, I can start applying and making connections and really understanding those different equations. So here's my functions graphed, and in the dynamic environment, you can change the way your axes are. So I am going to go into default zoom because I like it to be a little bit more 10:10, because it allows the students to see more quickly and make the connection between the function and the changes that you're making, because the points are a little easier to see. So let's move this up here. So horizontal shift. So we already learned that the negative positive opens it up or down. In the previous thing, they already know that if they put a coefficient with the x squared, they're going to make their parabola skinnier if it's a number larger than 1, and smaller if it's a number or absolute value that has an absolute value less than 1, right? And then they did also learn that if they add a constant, that's going to shift, vertical shift up or down, depending if it's positive or negative. So now we're going to focus on that horizontal shift. And to do that, we want to be changing the value of x. All right. So to do that, I'm going to kind of add in here my parentheses, and I'm going to add a positive 1. And so what I have done, I have added a value to x. So x now has a different value. And if students are making connections, they're thinking, okay, well, when we added that constant, it moved it to up if it was positive, or down if it was negative. So if you add a positive value to this variable and then you square it, this should move your function to the right. Logical guess, and that's the beauty of this dynamic, is you can just hit enter and, oh, it didn't go to the right, it went to the left. That's interesting. So maybe go down to the second one and do the same thing and say, okay, so if that moved it to the left, when you put in a positive value, what would happen if you put in a negative value? So you could now have them make a conjecture. Well, obvious conjecture is it's going to go to the right. So you can either add it as I like to, when I first start, add it as an actual negative value, just so they can see. And let's put that parentheses in. There we go. All right, so before you hit enter, this is a great thing about dynamic, is what do you think is going to happen? And they're going to go, well, it's going to go to the right 2 spots. So let's see. And it did, right? So this is the great thing about dynamics. You can make a conjecture and test it out. Now you want to start making some connections with that horizontal shift. So you want to click on the graph and look at some key points. And this is the vertex. And it's at -1, 0. The vertex of the red one is at +2, 0. So how does that connect to what we did? Well, we added a 1 and we moved the parent function that has a vertex of 0, 0. It went left 1, and now the vertex is -1. So that seems to make a connection. Same thing here. So you could keep working with this. So now if we said, okay, well, what if we want the f of x value to go to have a vertex of +6, 0, what would we have to do? And hopefully they're making that connection. You can come back up here and they say, okay, well, we have to add a -6 or subtract a +6, however you want to think about it. And there we go. We're at 6, 0. So you can really explore that. And now you can start adding on. And I'm not going to go too in depth here, but if they know that they left or right is going to be adding a positive or a negative. If they want to go right, they're going to add a negative. And if they want to go left, they're going to add a positive. And now if I want to go up, we already talked about that. So what if I said, okay, I want my g of x to end up with a vertex of -3, 4. Okay, so that means -3 is to the left, and 4 is up to the right. So how would I change this equation? They're really starting to make those connections, and that's the beautiful thing about it. So what did I think I said -3. So that means I have to have a +3, and then if I want to have my y value be 4, that means I vertically shifted up 4. I'm going to add 4. So this should hopefully get me to where I have a vertex of -3, 4, and they can try it out and they can test the point, and there it is. So this is what you should be doing with students. And the great thing is with this 991 scientific calculator with the QR capability is you have the handheld, and then you have the ability to do graphing and dynamic exploration using your mobile device and that QR code.